20 times. Like that. All those characters are there. And I am picking a character randomly. If I take it randomly, right, without any bias, right, so in that case, the probability will be, the first character will add 1 by n. Right? N is the total number of characters. Right? Is it clear? And if I take the second character is also n, right, so it will be f1 minus 1 by n minus 1. And probability of taking both the characters as the same, right, will be f1 by n into f1 minus 1 and n minus 1. Right? Is it okay? So this is the character, this is the probability of picking up two characters, right, which are the first character itself. Right? So what we are talking about index of coincidence, the probability of occurring two characters, if the characters may be anything, A might be B, etc. So in this case, what we have to do, the coefficient of coincidence, if I talk about Ci, is nothing but Fi into Fi minus 1, right, divided by n into n minus 1. I equal to 1 to 26. Right? Okay? And then if I calculate this coefficient of coincidence for each plain text language, natural language. So for English, it is always 0.0, I think it is 385. And for each particular language, this coefficient of is a coefficient of index because there is a particular distribution is there. And if all the characters are occurring randomly, that means they are occurring 1 upon n. Right? If there are 26 characters are there, each characters are occurring with a probability of 1 upon 26. Right? So it's a random one. So in that case, you calculate these things, the Ci might be, the Ci for English text will be this much, and Ci for a random text I might be wrong by some, but it is almost 2 times these 2 things. So in that case, what happens? So already have said the monoalphabetic cipher keeps the distribution of the symbols intact. Whatever distribution is there in the plain text, that same distribution is also exists in the cipher text. Only the symbols might differ. Are you getting my point? If the plain text symbol is this one like this, the cipher text will be also like this, right? So here it might be C. C is the most frequently occurring character. So in cipher text it might be say F. This is the most frequently occurring character. The characters that is there in the abscissa, that might be different, but the distribution is the same. Right? So in that case, the index of coincidence for a cipher which is generated from monoalphabetic cipher, right, will be around this value. And cipher which is generated from a particular cipher which is not monoalphabetic, a polyalphabetic, so it will be around the random ciphers, right? So from that we can distinguish whether a cipher is generated from monoalphabetic cipher or the polyalphabetic cipher. Is it clear this one? So now question is that how to start with, right? So I have to start with one of the way of this is that I can start with say 2 character. The key is 2. Then I will represent the symbols in 2 column. The cipher text symbol in 2 column. find out. So this, if this 2 column is the correct one, correct choice, right? So in that case, this column will be a ciphertext generated from monolithic cipher, right? So I will try to find out the index of coincidence. The index of coincidence is this one. So I can say that my assumption about the size of the key is correct. If it is not, then I will increase the value of 3. Then again I will arrange the ciphertext in 3 columns, and then I will again try to find out the index of coincidence of these columns, right? And if it is near to this one, then I can say it is correct. So this is one might be. Or what we can do, that we can guess something, right? From where we can start with, right? So that particular the first guess that has been given by a method, a particular this is called Kasitsky's test. Kasitsky's test. Kasitsky has given a particular way to find out the first approximate guess regarding the size of the key. Right? But then it has to be verified from the index of coincidence. So what Kasitsky says, that if you find same symbols, same group of symbols of at least length 3. So suppose a symbol is there, say TXE. It's a 3 character symbols, right? And again, say it is starting in say at position 1. Say around say this 2. Then around again say TXE. It is again occurring say 8. Right? Again at position say 16, TXE is occurring. So when I take the ciphertext, right, I find that a 3 character a symbol which is similar in 3 characters, right, is occurring multiple times at different positions. Right? So it is occurring at 4 positions, 8 positions, 16 positions. So in that case, can we assume that these characters might have been the same characters that is there in the plain text also, right? And they are since they are same character as the plain text, group of characters as the plain text, so they are also encrypted by same group of symbols in a key. Right? So we have already talked about this. This is lovely. So it might happen. Say it is TX. Some characters are there. Star, star, star. So I'm writing this as a P1, P2, P3. Again after some time, again lovely is repeating. Right? So again it is coming P1, P2, P3. So there are same symbols, right? And the same symbols are associated with the TX. Right? So if it is if this particular kind of thing we can assume. So in that case, what happens? The size of the key will be nothing but the highest common divisor between these two numbers, 4, 8, 16. Then only these symbols P1, P2, P3 will be mapped to the same information on the ciphertext TXE. So I can, from that kind of things, I can assume that might be my key size is of length 4. The 4 is the highest common divisor between all these elements. And then we will again try this kind of thing using index of coincidence kind of things, and then we will verify it. So this is how this particular cipher has been tried to be cryptanalyzed. Is there any question or you are feeling bored?
No, it's a very
irrespective of how much computational powers are there in the part of the cryptanalysis, you cannot break the cipher. Right? You do not assume anything in the part of the cryptanalysis. So whatever amount of informations are there, right? Whatever amount of ciphertext is there, whatever amount of plain text space is there, whatever amount of plain text ciphertext is there, you cannot break the cipher. So this is the ultimate everything perfect security model. So what we have missed out is that different cryptanalysis model is there, right? Based on the how much information is there in the hands of the cryptanalysis. Cryptanalysis is there to break the cipher, right? So he has to have some information out of which he can break the cipher. What are the information is there? I have already said it is not restricted. So algorithm is there with him. Right? What algorithm has been used? He has got in his possessions. He knows which algorithm has been used. It has been used in DS algorithm. So in case of say SSL, I am using AES algorithm. So that is known. Which key is used? That is unknown. Apart from that, what information he has got? He cannot get the value of k out of nowhere. Right? So on the basis of how much information is there in the hand of cryptanalysis, the different cryptanalysis models has been done. Right? Is categorized. So one is the ciphertext only model. Ciphertext only. So this is the least amount of information that the cryptanalysis is there. So if a particular cipher is resistant to ciphertext only attack, it is most secure. Right? Anyway, I can always get the ciphertext, right? And on the basis of the ciphertext and the relevant information, that is our encryption algorithm is known, right? I should be able to predict the key. Right? So this is the less amount of information that a cryptanalysis can have. Right? And if a particular algorithm is, if you can prove that it is resistant to ciphertext only attack, right? It is absolute. Right? There cannot be more than that. Right? Then second thing is that the plain text attack, plain text only attack. A little bit more information are there. Not only you have got ciphertext, right? But you have got the corresponding plain text also. Right? For a couple of plain text ciphertext. Right? So that information is also there. Right? So can you break the cipher? Right? So in that case, on the hand of cryptanalysis, two informations are there. Not only you have got ciphertext. Ciphertext is always possible. Right? You can always get the ciphertext. The information has been gone to the public channels. Right? You can always get hold of this thing. Right? But then, can you find out the corresponding plain text by somehow? Right? And then you can break the cipher. Right? So this is what the plain text only attack. Right? You have got plain text and ciphertext, and for some ciphertext you have got the corresponding plain text also. So can you break the cipher? So a little bit more information is there. The third thing is that Susan's plain text ciphertext attack. That means it is not only for a particular ciphertext you are getting the plain text, right? But you can select a plain text, right, and get the corresponding ciphertext, right? So that way, right, depending upon the amount of information that is available on the hands of cryptanalysis, the different attack models has been categorized, right? And one has to prove that if the algorithm is okay, that this particular text is resistant to this particular attack like that, and if a particular algorithm is resistant to this attack, right? So in that case, we can say this is ultimate, right? Right? It is a secure one. Now coming to perfect security, right? So they have talked about that irrespective of how much information that you have got, right? You cannot break the cipher, right? And then I will not be going into this thing, that one-time pad. Is shown by saying now that it is perfectly secure. So what is one-time pad? It's very simple. So what I do that, what I say that the size of the plain text and the key should be equal. Right? What is the amount of plain text is there and what is the amount of key is there, size of the key should be same. And once a particular key is used, right, that key cannot be reused. Right? That means it should be purely random. Right? So what do you say that is the size of key, if I say this like this, right, should be equal to k. Ciphertext is generated by P dot k, and third thing is the k is random. K is random. Right? So k cannot be repeated. Once we have used it, you cannot use it for. So is it possible? It is not possible. It is not feasible in practical field because, right, because of the key distribution problem. Right? If I have got a mechanism to send a key k or the length p, right, securely, right? Why don't you use that mechanism to send the p only? Okay. So there is no meaning at all. So only for a particular plain text I can do this particular kind of things, but for common kind of things I cannot do it.